Hi, fourth graders. This is Mrs. Hall again. I'm going to do a review video for lessons 14-6 through 14-10, which is mostly on the metric units as well as the units of time. So let's go ahead and get started with 14-6, which is using metric units of length. So we're going to be working with centimeters, millimeters, decimeters, meters, and kilometers. And so here are some examples. A ladybug is about a centimeter, so that kind of shows you how small a centimeter is. And a dime is a millimeter, so it's a millimeter in the thickness. So not the height or the width, but how thick it is. So when it's laying flat on a desk or a table, how thick is it? It's very, very, very thin, right? So that's 1 millimeter. 1 meter is about the length of a snake. So if you've ever seen Miss Hensley's snake, Sherlock, he's about 1 meter long. A kilometer is about the length of 4 city blocks. So you can see here, like this could be like maybe a couple houses long, like maybe 3 or 4 houses here, and then the next block over is another group of houses, and the next block over is another group of houses, and so forth. So that's about 4 city blocks. So this is the longest, right? The snake is kind of long as well. Millimeter is very small. Centimeter is small as well, not as small as a millimeter. And then decimeter, I don't see an example here. Let me see if we can go to the next page to see an example of a decimeter. Oh, they don't give an example. So the beetle is shorter than a decimeter, but longer than a millimeter. So that gives you kind of an idea. It's longer than a millimeter, but shorter than a decimeter. Okay, so let's do a couple examples here. The length of a cat. So I'm just going to do a couple from here and then move on. I'm going to spend most of my time in 14-9 and 14-10 as well. So we're going to choose the most appropriate unit to measure each item. So if we're looking at the length of a cat, number 2 here, what would we measure that with? Millimeters, centimeter, decimeter, meter, or kilometers? So if we look up here, well, the length of a cat's definitely smaller than the length of this snake here, right? So we're not going to use meters. A lot bigger than the dime, the thickness of a dime. Way smaller. Cat is way smaller than 4 city blocks. So centimeters, well, we could measure it with centimeters, right? Because we can think about it as like maybe being, 20 or 30 ladybugs long, right? So I would say that centimeter would be the best way to measure this cat. Now, what about distance traveled by plane? So if you are traveling by plane, would you measure that in millimeters? So think about how thick a dime is. That'd be a lot of millimeters to measure how far a plane is going, how far they're traveling, right? Even the meters, even a snake, that'd be a lot of snakes, right? A lot of meters to measure the length of the distance traveled by plane. Okay, so if we look at kilometers, going 4 blocks, that's a lot longer, right? That's our longest measurement, our longest way of measuring in this, and when we're using metric units of length. And so kilometers would be the way that we would measure the distance traveled by a plane. Okay, so let's go on to metric units of capacity. This is 14-7. So capacity is going to measure like how full something is. Typically it's with liquid, but it could be with other solid things as well. So we have milliliters. So that would be like a little droplet. So this might be like you can think of maybe something, an eyedropper, like somebody's putting eye drops into your eyes. That could be measured by milliliters. A liter would be like a water bottle. And most water bottles The taller water bottles, most of them are liters. The ones you can buy at the store or the ones that you buy that are reusable, like this one. And then this here is, let's go to the next page. That's actually showing something a little bit different. That's showing that the bottle has a capacity of 2 liters. So that's just a bigger form of a liter. Okay. So if we go into our practice, which is the best estimate for the capacity of each item. So if we look at this juice bowl, punch bowl, would we say that there's 5 liters in this or 500 liters? So if we go back up here, if this water bottle is 1 liter, we would definitely not pour 500 bottles of water into this punch bowl, right? It would just be 5 liters. So that would be 5 liters. Let's look at this number 4, this not even sure what you would call that, but maybe like a little vial of something. You might use it in chemistry or or like just mixing different things. This kind of looks like what you might take medicine with, like if you're taking Pepto-Bismol because your stomach hurt, or some kind of antibiotics that you were taking through a liquid. Your parents might measure it out in this thing, and then it has a little, kind of like a little spoon on it that you would drink it with. So what would this be? Would this be 10 milliliters? Or would it be 1 liter? So this is typically pretty small, right? So could we fill this water bottle up and then pour that into here? No way. It would overflow like crazy, right? But could we fill up about 10 of these little eye droplet things, these little millimeters here, and fill them up into this little medicine thing or vial of something? Yes, definitely. So that would be 10 milliliters. All right, let's go on to units of mass. So this is 14-8. So these lessons are all a little bit more simple, where we're just kind of getting used to what these things are about. Uh-oh. Let me pause for a second while I figure out. Oh, no, I think it just... No, let's do this again. Okay. I'm going to pause for a second while I figure this out. Okay, I got it figured out. Sorry about that, guys. Okay, so lesson 14-8, units of mass. So we have grams, which would be about the weight. So remember, mass is about weight, how much something weighs. The weight of a dollar would be grams. So it's very, very light because a dollar barely weighs anything, right? 1 kilogram would be about this weight of a cantaloupe, so a little bit heavier. A brick is even heavier than a kilogram, right? So let's make sure there's nothing over here. Okay, so a brick, they're saying that a brick would be about 3 kilograms. So that means we could stick 3 cantaloupes onto one side of a balance like this here, and it would weigh about the size or the weight of a brick. So 3 cantaloupes to 1 brick. So they're kind of giving you idea of how much a brick would weigh. Okay, so we got grams and kilograms. Okay, so let's look at these two here. How would we measure a hamster, or how would we measure the weight of a hamster, the mass of a hamster? So if we look up here, a hamster is not going to be as heavy as a cantaloupe, right? A hamster is going to be a lot lighter than a cantaloupe. So if it's not as heavy as a cantaloupe, which is equal to 1 kilogram, then we have to go down to another type of way to measure weight or mass, and that would be grams. So we would measure the hamster with grams. But now look at this gorilla. This gorilla has a lot more weight than one of these dollars, right? And it's even a lot more than this this cantaloupe, which is 1 kilogram. So we're actually going to measure the gorilla using kilograms instead of grams. It'd be an easier way to measure. Okay, so let's go into 14-9. This is where we're going to spend a little bit more time. Now here we have our conversions because this is about changing the metric units. So just like we change the customary units, we can change the metric units in order to compare something or just use different measurements to look at something. So let's go ahead and look at, it's on our next page. Let's go ahead and look at some of these practice problems. We're going to actually look at the ones down here on the independent practice, okay? And I'm going to show my whiteboard here so you can see how I work these problems out. Okay, so let's look at number 12. So we have 8 kilometers is equal to how many meters, okay? So they're giving us something here to help us, right? So what they're basically giving us, they're giving us 8 times 1,000 is equal to how many meters. Now, the reason why they do that is because 1 kilometer is equal to 1,000 meters. So if we multiply this by 8 to get 8 kilometers, we have to do the same to the other side here. We have to do the same to the other side here. So we would multiply this by 8. And that would give us 8,000 millimeters. So our answer would be 8,000. So they're kind of skipping this step. I like to write this step to show what I know, to show I know that this is equal to this. And then I like to multiply by both sides. But if you understand that very well, then you can probably skip that part and just go straight to this, the 8 times 1,000. So then our answer is 8,000 meters. Okay, let's go on to number 13. So 13 is showing 6 liters is equal to how many milliliters? So once again, they're showing us 6 times 1,000 is equal to how many milliliters? Okay, so they're doing that because 1 liter is equal to 1,000 milliliters. And if we wanted this to equal 6 liters, like it shows up here, then we need to multiply this by 6 here. And whatever we do to this side of the equal sign, we have to do to this side of the equal sign. So we're going to multiply this by 6 to get 6,000 milliliters. And so our answer is 6,000 milliliters. So 6 liters is equal to 6,000 milliliters. Okay, so let's go ahead and do a couple down here. So let's do number 18. We'll skip to 18. So 18 shows 100 milliliters and 1 liter. Okay, so if I go back to this page over here where it shows me some of my conversions, I can see that 1 liter is equal to 1,000 milliliters. So let me write that down. So I know that 1 liter is equal to 1,000 milliliters. And it may make more sense for you to write it this way. 1,000 milliliters is equal to 1 liter, only because there's liters here, and then liters here, and then milliliters here, and milliliters here. So let's actually leave it like that. It doesn't really matter what's on each side of the equal sign as long as we know that they're equal, right? So if we look at this, let's go back to our question here. If we look at this, well, if this is equal, what does that mean for this up here? So this is less, right? 100 is way less than 1,000. So then this must be less than 1 liter since these two are equal, okay? So because 1,000 milliliters is equal, sorry guys, is equal to 1 liter. That means 100 milliliters is going to be less than, oh, I'm still on my eraser, is going to be less than 1 liter. Okay, so let's do one more of those. Let's do kilograms and grams. Let's do number 20. So if we have 2 kilograms and 200 grams, we have to determine which one is bigger than the other. Now I know that 1 gram, I'm going to do it over here on this side since it makes a little bit more sense sometimes. 1 gram is equal to, sorry guys, I wrote that wrong. Okay, so 1 gram, I'm sorry, 1 kilogram, 1 kilogram is equal to 1,000 grams. Let me double check that. Let me look back here and make sure. 1 kilogram is equal to 1,000 grams. Did I write that right? Yes. Okay, 1 kilogram is equal to 1,000 grams. Okay, so when I'm comparing 2 kilograms to 200 grams, so that means that if I had 2 kilograms, so remember how we did our conversions last time and just a few problems ago? I'm going to times this by 2 to get 2 kilograms because that's what I'm working with up here. If I do that, I have to do this to this side. Sorry, these are equal to the other side. So because I times 2 to this side of the equal sign, I have times 2 to this side. And that gives us 2,000 grams. Okay, so 2 kilograms is equal to 2,000 grams. So now, if I look up here, well, 200 is way less than 2,000, right? So that means that 2 kilograms is greater than 200 grams. Okay. All right. So now I would like to go, I think if I go to our next page, we get our word problems here. Okay. Okay. So I would like to work with numbers 29 and 31 right now. So number 29. It says, Edgar says a giant tortoise is faster than a spider because 450 is greater than 31. Is he correct? So 450. So if we look at our chart over here, it says the distance animals can travel in 1 minute. The giant tortoise can travel 450 centimeters in 1 minute. The spider can go 31 meters. Okay, so look at that. We have centimeters and meters. Those are different units, right? Different units of measurement. So we need to convert one to the other to make sure that he's correct, because just because 450 is greater than 31 does not necessarily mean that 450 centimeters is greater than 31 meters, because centimeters and meters are different, okay? So he is claiming that this is greater than. So is he correct? This is the question that we have to ask ourselves, right? So I'm not saying this is correct just because I'm writing it. I'm writing it to remind myself of what Edgar thinks. Okay. So if we're working with centimeters and meters, so I know that 1 meter is equal to 100 centimeters. 1 meter is equal to 100 centimeters. And I know that because back on my chart of the conversions on lesson 14-9 in the very beginning, it shows me that, okay? So I need to convert this 1 meter to 31 meters, right? In order to compare it. So times this by 31, and I get 31 meters. So whatever I do to this side, I need to do to this side, right? So I'm going to times this by 31. And here I get 3,100 or 3,100 centimeters. Okay. So that means that the tortoise, I'm going to put T for tortoise, he goes, sorry, hold on, guys. Okay, he travels 450 centimeters. And the spider, 450 centimeters in 1 minute. The spider, S for spider, the spider goes 3,100 centimeters per minute. So if we're looking at comparing those, let's go ahead and change colors and use this. If we're going to compare centimeters, 3,100 centimeters to 450 centimeters, is 450 greater than 3,100? No way. So this should actually be 450 centimeters is less than 31 meters or 3,100 centimeters. These two are equal to each other, right? These two are equal. Okay, let me scroll that up so you can see it a little bit better. Okay, so he is not correct. So that's important to change and convert into either centimeters or meters. Whatever you would like to do, you can do it either way.